Okay, when we left off, I finished the math here and I found out what 4 equals c. And we take that and we plug that back into this equation right here, because remember when we first came up with that equation, we didn't know what c was. So s of t equals t to the third minus 9t plus 9t squared. Did I forget to put the squared in? Uh-oh, is that going to change something? Hold on. Okay, so I forgot my squared there. Lana probably saw. Squared plus 24t plus c, and c equals 4. And not writing that squared there is not going to make a difference for this problem, since t equaled 1. 1 and 1 squared is the same, so I kind of lucked out there. I just forgot to put the squared there. So this is my equation. Now the question says, write an expression for velocity in terms of t. Here's velocity in terms of t. Write an expression for x or s in terms of t. Here it is right here. Determine the times of t when the particle's velocity is 0. So when the velocity is 0, we actually have to set v of t equal to 0. V of t is 3t squared minus 18t plus 24. I'm going to factor out a t. We get t squared minus 6t plus 8. Okay, we're going to get t minus 2 and t minus 4. Therefore, when t is 2 and 4, so when the time is 2 and 4, the velocity will be 0. And check it out. Describe the motion for the particle from t equals 2 to 4 seconds. Indicate both distance and direction. So we're going to actually check, 2 and 4, what's happening before and after. But really, they just want to know what's happening between. So we can pick the number 3 between. Put that in there. We're going to get 20. So we're going to get a big number. We're going to get, I'm going to put in the number 3. 3, why does this pen not work? 3 times 3 squared minus 18 times 3 plus 24. So I'm going to get 27 minus 54 plus 24. Well, 27, what's 27 and 24? That's 40, 51. 51 minus 54 equals negative 3. So we get a negative, and it says indicate both direction and distance. So the direction, it's moving left, and then my distance, I'd actually have to plug in 2 and 4 into distance. But I'm going to stop right there for that problem, because this is really like an advanced problem for such a beginning topic that we're just starting to talk about. So we checked the critical points. That's what we needed to do. Okay, I want to talk about one more thing. Let's say we have a problem like if s of t equals the integral of 0 to t of 3w squared minus 6w dw. Okay, what if we want to find the velocity and we want to find acceleration? Well, remember, to get from position to velocity, you have to take the derivative. And when you take the derivative of an integral, they cancel each other out. So we just have to take this t and substitute it in. So we're going to get 3t squared minus 6t times the derivative of t, which is just 1, so I don't have to worry about anything. Okay. Now that I have velocity, I can take the derivative again and find acceleration. So we're going to get 6t minus 6 is going to be the equation that represents acceleration. What if I were to ask you, find the positive direction the object is traveling? Well, what do we look at when we're finding what direction? It's not where our position is. Our position is just where are we on that graph. We want to know what is our speed, what is our positive, when are we moving forward? So what we're going to do is we're going to look at velocity. We're going to look at velocity to find the direction. And positive and negative will tell us the direction. So if I'm going, so I could be driving my car in the parking lot at school going forward at 5 miles an hour, but I could go in reverse at 5 miles an hour. Well, what tells you the direction is the plus sign or the minus sign. Okay, plus or minus tells direction. It doesn't tell the speed, it just tells you which direction you're going. So we know that v of t equals 3t squared minus 6t. And we want to find, we need to find our critical point. So we can determine whether we're going positive, when we're not moving at 0, our critical point where we possibly might change direction. Then we're going to check, just like the critical points, finding the maximum and the minimum. So let's factor this. I'm going to get 3t equals t minus 2. So we're going to get t equals 0 and t equals 2. So I'm going to check what's happening. We're going to do our first derivative test. We have 0 and we have 2. So what's happening on the left side of 0? Well, let's plug in -1. A negative times a -1 minus 2 is a negative times a negative is a positive. Let's plug in the number 1. We're going to get a positive times a negative. Here, when I plug in 1, 1 minus 2 is a negative. -1 times 3 is negative. Now let's plug in the number 3 or some other thing. I'm going to get a positive times a positive. It's going to be a positive. Okay. So my direction is positive. Okay. My direction is positive when t is less than 0 and t is greater than 2. Okay. Or I could write it from -infinity to 0 and from 2 to infinity. Okay, both of those check. Okay. Now, this is talking about direction. When I'm talking about direction, I'm looking at the velocity. But what if I want to know when is the object slowing down? Okay, that's actually talking about acceleration. Acceleration happens when you're either speeding up or slowing down. Like, I can accelerate or decelerate, right? Acceleration is either going faster or going slower. Well, what I'm going to do here is I'm going to check, find out what a sub t is. That equation we found above was 6t minus 6. Let's factor that one. We're going to get, or set that equal to 0. T minus 1 equals 0. So that happens when t equals 1. So we're going to look at what's happening to the left and right at 1. So when I put a 0 in, okay, because 0 is left of this, I get 6 times a negative number, I get a negative. When I put something greater than 1 in, I get a positive number times 6 is a positive number. Okay, so this is telling me about acceleration, but I want to actually look at when both charts have the same sign. Okay, so I'm going to take this chart and I'm going to overlay it on top of this one. So right here it's a 1, right? And I have negative over here and positive over here. So where do these two equations have the same sign? They have the same sign after 2, right? These are the same sign. And they also have the same sign between right. That's okay, because this is between right here. Between 0 and 1. Okay? So right here, in black, this is negative. Oh wait, that's not the same sign right here. Pause. Okay, so after 2, they have the same sign, and between 0 and 1 they have the same sign. But between anything less than 0, do you see how there's my velocity was positive but my acceleration was negative? But between 0 and 1, my velocity was negative, my acceleration was negative. Between 1 and 2, my velocity was negative, my acceleration was positive, and here they're both positive. Okay, so I want to compare the signs, and things will be slowing down when you have opposite signs. So we are slowing down between 0 and 1 and from 2 to infinity. And then things will be speeding up when signs are the same. So I have the same sign. Oops, I'm sorry. This is between infinity and 0. And same sign is between 0 and 1. Oh, I have this backwards. It is confusing. Hold on. The opposite signs are between negative infinity and 0. Same sign between 0 and 1. Opposite signs between negative infinity and 0, and between 1 and 2. Here we go. And then here is 2 and infinity. Ah, this is a 2. Bless me. All right. So the hard part is, like, you have to put these two graphs together and then look for the overlaps. It might have been easier if I put the if I had done it like this. Let me just kind of redo this for us. 0 and 2. This is positive, negative, positive. And then for our acceleration at 1, this is negative, negative, positive, positive. So now it's easy to see that these are the same here and different here. These are different here and the same here. All right? We'll do more practice with this as we move forward.